is a branch of mathematics which deals with the data collected for specific purposes. By close observation and evaluation, one can make successive decisions about the data. There are many methods of representing data graphically and in tabular form. Sometimes, when data is represented, either clustering or scattering occurs, where measures of central tendency are not sufficient to give complete information. So we chose another parameter called measures of dispersion, which can be used to describe the variability in a data set. And in this video, we are going to deal with one measure of dispersion, that is mean deviation. Mean deviation is defined as a statistical measure that is used to find the average deviation from a central value A. It is the mean of the absolute values of the deviations of the observation from A. Mean deviation from A is denoted as MD of A, and the mathematical representation is sum of absolute values of deviations from A divided by the total number of observations. The simple meaning is that it tells us how far all the observations are from the middle or average value. Mean deviation may be obtained from any measures of central tendency. That is, one can find the mean deviation about mean deviation about median, and mean deviation about mode. But however, mean deviation from mean and median are only commonly used in our statistical studies. Here, we are focusing only on the methods to find the mean deviation for ungrouped data and the grouped data. Let us first learn mean deviation for ungrouped data or raw data. Consider there are n observations, x1, x2, x3 up to xn. First, we need to find the measure of the central tendency, about which we are to find the mean deviation. Let it be A. Next, we need to find the deviations of each xi from A, that is x1 minus A, x2 minus A, like that xn minus A. Next, we need to find the absolute values of the deviation. That is what we have got in the second step. Take the absolute value. So we get modulus of x1 minus A, x2 minus A, like that modulus of xn minus A. And the last step is to find the mean of the absolute values of the deviation, which is nothing but the required parameter. That is our mean deviation. And its mathematical representation is mean deviation of A is equal to 1 by n summation I equal to 1 to n modulus of xi minus A. If the central value is mean, then the mean deviation will be modulus of x bar, which is equal to 1 by n summation I equal to 1 to n modulus of xi minus x bar, where x bar is the mean. Now suppose if we need to find the mean deviation from median, the equation will become mean deviation about median is equal to 1 by n summation I equal to 1 to n fi into modulus of xi minus m, where this m represents the median. Let's see one problem for better understanding. Find the mean deviation about the mean for the following data. The data is 12, 3, 10, 4, 8, 12, 9, 3 and 2. So first we need to find the mean, that is our x bar of the given data. How will we find? Just add the values, then divided by the total number of observations. So we get x bar is equal to 12 plus 3 plus 10 plus 4 plus 8 plus 12 plus 9 plus 3 plus 2, the whole divided by 9, which is equal to, so 63 by 9 we get it as 7. Next, we make a table showing the values of xi and xi minus x bar and its modulus value. So for the value of 12, modulus of xi minus x bar, that is 12 minus 7, we get it as 5. Now for when xi is equal to 3, we get modulus of 3 minus 7, that is modulus of minus 4, and we get it as 4. We take only the positive value. Now when xi is equal to 10, we get modulus of 10 minus 7 is equal to 3. When xi is equal to 4, we get it as modulus of 4 minus 7, which is equal to 3. When xi is equal to 8, modulus of 8 minus 7, we get it as 1. Again, value is 12, we have already calculated here, and the value is 5 here. Now when xi is equal to 9, what will be the value? Modulus of 9 minus 7, we get it as 2. For value of 3, value is 4, and when xi is equal to 2, modulus of 2 minus 7, that is 5. Now the mean deviation is given by md of x bar is equal to the standard equation, that is summation I equal to 1 to 9 modulus of xi minus x bar the whole divided by n, and we get it as add all the values divided by 9, that is 5 plus 4 plus 3 plus 3 plus 1 plus 5 plus 2 plus 4 plus 5 the whole divided by 9, and we get it as 32 by 9, and the final result is 3.555. This is a mean deviation about mean. Next, let's discuss about the mean deviation for group data. In group data, the number of times each value occurs, or we say the frequencies of particular value or observation will be given. Again, the group data can be divided into two, that is discrete frequency distribution and continuous frequency distribution. Now, my question is, what is this discrete frequency distribution and continuous frequency distribution? How can we identify them from the given data? Discrete frequency distribution is one in which the data can take only certain values, while in the case of continuous frequency distribution, in which the data can take on any value within the specified range. Here the data classified into different class intervals without gaps along with their respective frequencies. Let's now discuss what is discrete frequency distribution. Let the given data consist of n distinct values, that is x1, x2, x3, xn, occurring with the frequencies f1, f2, f3 up to fn. Now let's discuss the mean deviation about mean. The first step is to find the mean using the formula x bar is equal to 1 by n into summation I equal to 1 to n xi into fi, where summation xi into fi is the sum of the products of the observation xi with their respective frequencies, and n is the sum of frequency, that is summation fi. Next, we need to find the mean deviation about mean, which is the mean of the absolute values of the deviations, and the formula is 1 by n summation I equal to 1 to n fi into modulus of xi minus x bar. Now, what will be the mean deviation about median? The only difference is that instead of mean, we need to find the mean deviation with respect to median. Now, for finding median, we need to first arrange the observations in the increasing order. Then, the cumulative frequencies are found out. Then we try to identify the observation whose cumulative frequency is just greater than or equal to n by 2. Surprisingly, this value of the observation lies in the middle of the data, which is the required median. And after finding median, we use the formula to find the mean deviation. And the formula is mean deviation with respect to median is equal to 1 by n summation I equal to 1 to n fi into modulus of xi minus m, where m is the median. Now, let's move on to discuss what is continuous frequency distribution. Under this, we need to discuss mean deviation about mean and mean deviation about median. Formula and procedures are all remain the same for both cases as we did in the previous case, that is discrete frequency distribution. If it is mean deviation about mean, find mean wherever required, and if it is median, find median. But certain things to be noted in finding mean and median for a continuous frequency distribution. In the first case, while calculating the mean of a continuous frequency distribution, we have to make an assumption that the frequency in each class is centered at its midpoint. So, we write the midpoint of each given class interval, which acts as our xi. Then we proceed further as we did for discrete frequency distribution to find the mean deviation about mean. Now comes to the second case. For finding median, we need to arrange the data in the ascending order, that is the first step. Then we need to identify the median class in which the median lies, and then applying the formula. And the median is given by L plus n by 2 minus C divided by F into H. Let's see each parameter one by one, where the median class is the class interval whose cumulative frequency is just greater than or equal to n by 2. What is that n? N is the sum of frequencies. Now what is L? L represents the lower limit. What is F? Represents the frequency. H represents the width of the median class respectively. And C represents the cumulative frequency of the class just preceding the median class. Then we use the main formula to find mean deviation, that is mean deviation about median is equal to 1 by n summation I equal to 1 to n Fi into modulus of xi minus m. Let's see one problem for better understanding. Calculate the mean deviation about the mean for the following data. This is the data. It's a data showing the marks obtained versus the number of students. First, we need to make a table. The first column is the marks obtained. The second column refers to the number of students, which will give the Fi. The third column refers to find the midpoints, which will be our xi values. And the fourth column to find the product of Fi into xi. And the fifth column is to find the absolute value of deviation, that is modulus of xi minus x bar. We are finding with respect to mean. And the sixth column is the product of Fi and modulus of xi minus x bar. So let's see one by one. For the class interval 0 to 10, Fi is 2 as per the data, xi is equal to 5. Now what is Fi into xi? 2 into 5, we get 10. Now modulus of xi minus x bar is 22 and Fi into xi minus x bar is 44. Now for the class interval 10 to 20, Fi is 3, xi is 15. How? The midpoint of 10 and 20. Then Fi into xi will be 3 into 15, we get 45. Modulus of xi minus x bar is 12 and Fi into modulus of xi minus x bar is 36. Now for the class interval, again we have to find the values. That is, we get Fi into modulus of xi minus x bar is 8, modulus of xi minus x bar is 2. Remaining values we can find it from the given data. Now for the class interval 30 to 40, similarly we have to find the values. For the class interval 40 to 50, Fi value is 2, xi value is 45, Fi into xi is 90, then modulus of xi minus x bar is 18, then Fi into the product of Fi into modulus of xi minus x bar, we get it as 36. Again for the class interval 50 to 60, we need to find out in the same manner, and you can see that. So what is n? N is the sum of frequencies, that is all Fi's add up to 15. Now we need to find summation I equal to 1 to 6 Fi xi. We have to add up all Fi into xi, we get it as 405. Now the summation I equal to 1 to 6 Fi into modulus of xi minus x bar, we get it as 176. Now we have to find x bar, which is equal to 1 by n summation I equal to 1 to 6 Fi into xi. Substituting the values, we get 405 by 15, which is equal to 27. And we have to consider this value as the assumed mean, that is A here. Alright. Next, we need to find the mean deviation about the mean, that is MD of x bar is given by, which is equal to A, that is our assumed mean, 1 by n summation I equal to 1 to 6 Fi into modulus of xi minus x bar. Substituting the values, we get it as 176 by 15, which is equal to 11.73. But this method projects out two limitations. Can you identify? In a series where the degree of variability is high, mean deviation cannot be fully relied on, gives unsatisfactory results. Moreover, mean deviation is calculated on the basis of absolute values of the deviation. It cannot be subjected to further algebraic treatment. So these two reasons project out the limitations of mean deviation. Hence, we must find out some other measures of dispersion which will be discussed in detail in our next video. Now, let's summarize the entire section.
Manorama Horizon. Learning made simple.